The Mesan Curring, a storm surge barrier in the Rhine Delta, is unique for being the world's largest moving structure, weighing 12,000 tons of steel. Built at a cost of €450 million, this barrier is a vital safety measure to protect lives from flooding, a crucial investment for the Dutch, who are leaders in water management. The Netherlands focuses on prevention rather than reaction, preparing so well that disasters are averted. This commitment began in 1937 when studies showed that high water levels posed a severe threat, especially near the Rhine, Maas, and Scheldt River mouths. The Delta project aimed to block these waterways, but it took years to develop. The 1953 North Sea flood, which claimed 1,835 lives and submerged over 370,000 acres in the Netherlands alone, underscored the need for urgency. In response, the Delta Committee was formed, leading to the Delta Works project, which ran from 1954 to 1997. This project created dams, dikes, locks, and storm surge barriers to protect South Holland, home to nearly 4 million people, most below sea level. Without these defenses, a major flood could be catastrophic, especially given the speed of North Sea storms, which offer little time for evacuation. About 26% of the Netherlands is below sea level, and in a significant flood, up to 59% could be submerged. We're not diving too deep into this, as we recently covered flooding in the Netherlands. Check that out on our channel. Now, let's focus on the Delta Works project, which can handle tidal waves up to 16 feet. Today, I want to highlight the storm barriers, starting with the Mesan barrier. It has the largest movable parts of any flood protection system worldwide. The Mesan barrier is the first line of defense during a storm, protecting South Holland from surges. Construction began in 1991, and after 6 years, it was opened by Queen Beatrix in 1997, an important moment for the Netherlands. Normally, the gates stay in their dry docks, allowing a 1,180-foot gap for ships to pass, which is crucial for the Rotterdam North Sea route. This waterway connects to the port of Rotterdam, which, when the barrier was completed, was the largest in the world. A solid dam would disrupt this major shipping route, so they opted for movable gates. About 300 ships pass through the Mesan barrier daily, and closing it would cost the port €10 million per day. But the cost of a flood would be far higher, so it's a choice between two evils. The barrier is built to withstand a storm that only happens once every 10,000 years. It was constructed in dry docks, keeping key parts above water for easier maintenance and longer lifespan. When open, the gates don't interfere with ships. But how do they protect the land if they stay on land? Let me explain. Each gate measures 690 feet wide, 72 foot tall, and 49 feet deep. When closed, they fill with water and sink to the bottom in about 2 hours. The system uses a 33-foot diameter, 680-ton spherical bearing. The gates close automatically at water levels 10 feet above Nap in Riram and 99.5 feet above Nap and Dora, with Nap being an updated version of 17th-century sea level measurements. While the process is automated, Rijkswaterstaat staff monitor it during flood forecasts and intervene if necessary. Ships are alerted 4 hours prior, and the new waterway is closed 2 hours before. 30 minutes before the closure, the dry docks are flooded, and the gates descend, moving toward each other with the help of locomobiles until they are about 5 feet apart. Water enters the gates' recesses, and they sink, forming a watertight seal over a gravel base. When the gates stay closed for an extended time, river levels rise but are managed by the gates' built-in indentations, which let water drain and flow into the sea before the gates sink again. The barrier's automation is managed by software written in C++, with 200,000 lines for the operating system and 250,000 for simulation. It first shut down during a storm in 2007 and nearly did so in 2002, 2013, and 2014, emphasizing the precision of the system. The water level needed to activate the barrier was just inches away back in 2007 when the threshold for closing was lowered from 10 feet to 9 feet. This wasn't due to any urgent concerns but to test the barrier under real conditions. Despite being operational since 1997, it had never been used in practice until December 21, 2023. On that day, the Mesan Curring barrier closed for the first time, showcasing its effectiveness after 26 years. While Storm Pia impacted other European countries, the Netherlands stayed safe, though a man died due to a falling tree, not flooding. Initially, the barrier was expected to close every 10 years due to storm surges, but rising sea levels mean it may now close every 5 years. Interestingly, the Mesan Curring was never part of the original plan. The initial idea was to reinforce dikes up to 30 miles inland, but by the 1980s, this would have taken at least 30 years and a huge budget, not to mention demolishing centuries-old historic city centers. This plan was abandoned, and instead, a storm surge barrier was chosen, with some dam constructions completed only partially. However, challenges remain. The sea level has already risen by about 8 inches since the 20th century, and by 2100, it's expected to rise 12 inches, 4 feet. This means closures may need to happen annually, which is not ideal for port management. Besides the economic impact, increased usage puts strain on the barrier, which wasn't designed for monthly closures. The Mesan Curring has reached its maximum weight capacity and can't be reinforced further. Unpredictable weather also limits maintenance. Current estimates suggest it can protect the Netherlands until at least 2070, but its future adaptations remain uncertain. We've talked enough about the Mesan Curring, so let's shift our focus to another barrier, the Hollanda ISO River Barrier, the first structure of the Delta Works project. During the 1953 flood, dangerously high water levels put 1.5 million people in the Randstad area, home to Amsterdam, Rotterdam, The Hague, and Utrecht, at risk. Given that the Hollanda ISO is a key shipping route, a permanent dam wasn't feasible. Instead, they built a storm surge barrier with 2 movable sluice gates between concrete towers that close only during severe flooding. Construction began less than a year after the 1953 disaster and was completed in just 4 years, a remarkable feat for the 1950s. The towers stand 148 foot tall, the gates are 39 feet high, 262 feet wide, and spaced 443 feet apart, each weighing 480 tons. A traffic light system was installed. Red lights indicate closed gates, while blue means open, making them visible from far away. The gates close more frequently than the Mesan Curring, about 3 to 4 times annually, as the dikes behind them can only withstand water levels up to 7.4 feet above sea level. After the Mesan Curring's construction, there was consideration to shut down the Hollanda ISO barrier, but the economic impact was deemed too high. Both barriers are part of the same flood protection strategy, with the Mesan Curring used only for extreme events. Fortunately, these high water scenarios are rare, as shown by the gates being used just once in 26 years. Next up, the Oosterschelde, the largest barrier, located between Schouwen-Duiveland and Noord-Beveland. This is the largest storm surge barrier of the Delta Works project. Spanning 52 miles, it was initially designed as a closed dam. However, after public protests, floodgates were added along the last 2.5 miles. These gates remain open under normal conditions but close during bad weather, protecting the land, preserving sea life, and supporting fishing. Construction, which lasted from April 1976 to June 1986, made this the most challenging and expensive part of the Delta Works. To simplify construction, a 700-acre artificial island, Neeltje Jans, was built. It housed everything needed: power stations, concrete plants, ports, and roads. Prefabricated elements like the 65 concrete pillars and 62 steel gates, each 138 feet wide, were assembled on-site. The pillars, weighing 18,000 tons and standing up to 127 foot tall, were constructed in a pit below sea level and transported using a lifting vessel. The barrier, designed to last over 200 years, requires maintenance costing €17 million annually. Its gates have been closed 28 times since 1986, most recently on January 31, 2022, during Storm Corey. Beyond flood protection, the barrier preserves the area's rich biodiversity, including rare seals and porpoises, while also providing educational and recreational opportunities. The barrier keeps the water salty and preserves the tidal effects, making the area a hotspot for water sports like surfing and kite surfing. It's also a culinary treasure. During low tide, visitors hunt for oysters and shellfish. This wouldn't be possible if a fixed dam had replaced the movable structure. Interestingly, the Oosterschelde King, often called the eighth wonder of the world, was officially named one of the modern 7 wonders by the American Society of Civil Engineers. Another notable barrier is the Hardak Curring in Spissa, part of the Delta Works project. It lowers 2 massive gates to the seabed to guard against high water, with slides that stand 46 feet high when open. These gates can handle water levels up to 10 feet above sea level and feature openings of 161 and 322 feet wide. The lifting cylinders, Europe's largest at the time, ensure smooth operation. Built between 1991 and 1997, its automation and closing conditions are similar to Mesan Curring. However, there's no record of the Queen attending its grand opening. Today, we explored barriers against water, but the Netherlands goes beyond that. Take Rotterdam, for example. 80% of the city lies below sea level, with some areas as much as 22 foot lower. Instead of relying solely on dams or barriers, the city uses innovative strategies like rainwater management. Parking lots now have tanks that store rainwater during storms and release it gradually, easing drainage systems and conserving water for droughts. Rotterdam also launched the Sponge Garden project to test water management methods, such as planting low-maintenance vegetation and improving soil in private gardens. These efforts help absorb excess water while encouraging community participation. The Dutch continue to set the standard for water management. On the shores of Chesapeake Bay, much like the Netherlands, the marshy land and filled-in streams have led to persistent problems like land subsidence and rising sea levels. While these issues aren't new, they've worsened recently due to climate change. And who better to handle water challenges than the Dutch? That's why cities like Norfolk, New Orleans, and Charleston have sought help from the Netherlands, as they all face similar struggles with rising waters. Water management has become a specialty for the Netherlands, often compared to Silicon Valley but in this field. To address these challenges, Dutch experts in landscape design, hydrology, and engineering have been called in to develop innovative solutions. The Living with Water program, a 50-year initiative, focuses on modernization and urban design strategies to manage water. Its primary aim is to slow down and capture rainwater, circulate surface water, and replenish groundwater, rather than simply pumping it out. Speaking of water challenges, the UK faced a severe crisis in 2014 when flooding devastated the Somerset levels, affecting over 600 homes, 177,000 acres of farmland, and a railway. In response, the Netherlands provided 8 powerful pumps to handle the disaster. Dutch and British engineers worked together to install the pumps and drain the excess water, showcasing the Netherlands' expertise in water management. The Netherlands' deep connection to water is showcased by Hut Braineville, meaning broken wheel. This unique residential area and tourist spot lies between the Fayen Lakes and Lake Assare, the country's largest lake. Built in 1992, it spans 27 acres with 230 homes surrounded by water, offering every resident access to the canals and a car parking spot. By 2022, homes here were priced at over €350,000, making it a sought-after location. Another standout is Vijnen Vin Plassen, a housing complex of narrow land strips extending into the lake, blending nature with innovative design and turning a challenge into a remarkable attraction. But let's get back to the dikes and gates, the main defense keeping the Netherlands safe from floods. A Dutch scientist at the Royal Netherlands Institute for Sea Research proposed a bold solution to protect 25 million Europeans from rising sea levels, 2 colossal dams sealing off the North Sea. One would span 295 miles from northern Scotland to western Norway, while the other would stretch 100 miles between western France and southwestern England. This ambitious project, called the North Sea Dam, would cost an estimated 250 to 500 billion euros. Spread over 20 years, that's just over 0.1% of the GDP for the 14 nations it would protect, a manageable expense. Technically, it's feasible. The sea depth between France and England is mostly under 330 feet, while the Scotland-Norway section averages 417 feet, with a max of 1,500 feet near Norway. Given that modern platforms can handle depths over 1,640 feet, building such dams is well within reach.